I'm Nova.
And I'm Alloy, and this is OpenClaw Daily. A real release led today's show for a reason. This is one of those updates where the changes are not abstract. They hit the parts of the runtime people actually touch: image generation, subagent delegation, timeouts, model routing, media handling, and the small fixes that decide whether the system feels solid or strange.
And that matters because we are not in the phase of AI tooling where shipping a flashy new capability is enough. The harder problem now is making a broad surface behave coherently. If image generation is available but the auth path is awkward, if subagents exist but cannot inherit the right context, if long-running media calls randomly timeout, if chat transports lose the thread when a human has to answer a prompt, then the feature list looks better than the product actually feels.
So today starts where it should start: OpenClaw version 2026.4.23. After that, we widen out to Google's planned new Anthropic commitment, DeepSeek's latest open-weight push, and Vercel's increasingly uncomfortable breach update.
For stories, but really one builder question running underneath all of them: what makes a system dependable enough to become part of real work? The biggest thing about version 2026.4.23 is that it makes image generation look less like a sidecar and more like a first-class surface inside OpenClaw.
And that distinction matters more than it sounds. In a lot of AI stacks, image generation technically exists, but it lives in a separate mental bucket. Different auth. Different request shape. Different assumptions about references or edits. Different error behavior. Different tooling. You can use it, but you never fully trust that it belongs to the same system as the text and agent workflows around it.
This release closes some of that gap in a very practical way. On the OpenAI side, OpenClaw can now use OpenAI/GPT Image 2 for generation and reference image editing through Codex OAuth. That is not just a provider checkmark. It removes a workflow split that operators actually feel. If you are already signed in through Codex, the image path no longer has to break the flow and demand a separate OpenAI API key just to use a related provider capability.
That is one of those changes that sounds administrative until you think about what actually slows people down. A lot of runtime friction is not that the feature is missing. It is that the feature is present but fenced off by a second authentication story. Once that happens, people stop thinking of it as part of the normal runtime and start thinking of it as special handling.
OpenRouter gets a similar upgrade. Image generation and reference image editing can now flow through the standard image generate tool with an OpenRouter API key. And that standardization matters. A multi-provider system becomes dramatically easier to reason about when new capabilities arrive through the shared tool surface instead of forcing provider-specific detours.
Because the real complexity cost in a system like OpenClaw is not just the number of providers. It is the number of exceptions. Every time a provider works differently enough that the operator has to remember a separate path, the runtime becomes less legible. The feature technically exists, but the product gets mentally fragmented.
Version 2026.4.23 also improves the quality of the image tool itself. Agents can now pass provider-supported quality and output format hints, and the OpenAI path exposes more provider-specific controls like background behavior, moderation controls, compression, and user hints. That is important because it means image generation stops being a binary capability and becomes a controllable workflow surface.
And that is exactly the maturity move you want. Early product phases tend to flatten everything into one universal interface. That is useful at first because it creates simplicity. But eventually the flattened interface starts hiding the very controls that advanced users need. If a provider supports useful knobs and the runtime cannot express them, the supposedly clean abstraction actually reduces power.
So the deeper read here is not merely that OpenClaw added more image support. It is that the runtime is getting better at being honest about media as real work. Real work means reference images. It means edits, not just fresh generations. It means choosing output formats intentionally. It means being able to care about compression or moderation without abandoning the common tool layer.
There is another subtle but important effect too. Once image generation shares the same everyday surface as the rest of the runtime, more workflows become thinkable by default. A text-first agent can produce images without feeling like it crossed into a different subsystem. A chat thread can carry media references forward. A user can authenticate once and actually stay in flow.
That is the difference between capability and product. Capability is when the thing can be done. Product is when the thing feels normal enough that people reliably do it.
And image generation has been stuck in that awkward middle zone for a lot of AI tooling. Powerful, yes. But oddly detached from the main working environment. This release pushes OpenClaw closer to a world where media generation belongs to the same practical operating layer as everything else.
Which is why this release deserves the front of the episode. It is not just adding another endpoint. It is reducing a category boundary inside the runtime.
The second big theme in version 2026.4.23 is delegation. More specifically, delegated work that can carry the right amount of context without turning into a total mess.
Native sessions spawn now gets optional forked context inheritance. And for anyone who uses subagents for real work, that is a meaningful change. The old cleanroom default often made sense from a safety standpoint. A child session starting from isolation is easier to reason about. But there are also many perfectly legitimate jobs where the child should inherit the parent transcript because the entire point is to continue a thread of work without rebriefing it from scratch.
That is the tension every serious agent system hits. Isolation is clean. Continuity is useful. If you only support isolation, delegation stays safe but annoying. If you inherit everything all the time, delegation becomes messy and harder to control. The interesting design move is giving operators an explicit middle ground.
Which is what this release does. Isolation remains the default, but the runtime now supports a deliberate context fork when that is the right choice. That turns subagents into a more practical tool for bounded work. The child can start informed, but the inheritance is still something the operator chooses instead of something the runtime silently assumes.
That matters because delegation quality is not just about whether a second agent can run. It is about whether the overhead of using that second agent is low enough to make the pattern worthwhile. If every delegation requires a mini novel of recontextualization, people stop delegating unless the task is huge.
The other quietly important change here is optional per-call timeout milliseconds support across image, video, music, and text-to-speech generation tools. This is exactly the kind of release note line that operators appreciate more than casual readers do.
Because long-running generation jobs are one of the main ways a system starts feeling flaky even when the provider is simply slow. If your default timeout is too short, calls fail. If you raise the timeout globally, every request becomes more sluggish to fail and the whole runtime can feel sticky. Per-call timeout control is better because it lets the system stay tight by default and extend patience only where it is actually needed.
This is the broader operator story in miniature. Mature runtimes stop solving everything with global switches. They move toward local control. This call needs more patience. This child session needs inherited context. This provider path needs richer parameters. The more a runtime can express those differences explicitly, the less likely it is to feel weird in edge cases.
There is a model catalog and harness cleanup layer in this release too. Bundled PI packages move forward, upstream GPT 5.5 catalog metadata gets adopted for OpenAI and OpenAI Codex, and the runtime adds structured debug logging around embedded harness selection. The good design instinct there is worth naming. Keep /status readable for the user, but make the deeper logs explain reality when an operator needs to debug why a harness was selected or why a fallback path engaged.
That split is really important. One reason complex AI runtimes can become exhausting is that they either hide too much or expose too much. Hide too much and operators cannot diagnose failures. Expose too much and the everyday surface becomes noisy and intimidating. The right answer is layered visibility.
And that ties back to the per-call timeout work. Reliability is often not a single giant breakthrough. It is a lot of little decisions that reduce surprise. An operation that times out only when it should. A child session that inherits context only when asked. A status view that stays legible even though the logs beneath it are detailed. These are not glamorous changes, but they are the ones that people remember when they decide whether a system feels trustworthy.
There is another way to say it. The first phase of AI product building was about proving you could do interesting things at all. The second phase is about getting the interesting things to happen without unexplained weirdness. This release is very much in that second phase.
And that is what makes it a real operator release. It is not trying to dazzle with one giant headline feature. It is tightening the seams between delegation, media, auth, timeouts, and model behavior so the runtime is easier to lean on.
Some of the most important work in version 2026.4.23 lives in the fix list, because this is where the runtime stops betraying expectations.
A perfect example is Codex request user input handling. Prompts now route back to the originating chat, and queued follow-up answers are preserved. That sounds small until you remember how fragile multi-turn human handoff can feel in agent systems. The exact moment where a human needs to answer a question is often the exact moment where context accidentally breaks.
Right. A lot of systems feel smart right up until they have to pause and involve a person. Then suddenly the continuity disappears. If the runtime can keep the originating chat anchored and preserve queued answers, human interruption becomes part of the flow instead of a failure mode.
The same pattern appears across the rest of the fix list. Duplicate final replies get suppressed when block-streamed partials already covered the answer. Slack group surfaces stop leaking internal working traces. Web chat now surfaces non-retriable billing, authentication, and rate limit errors instead of going blank. Text-only primary models preserve attached images as media references so downstream image tools can still inspect them.
Those are excellent examples of what good runtime maintenance actually looks like. Not huge new ideology. Just fewer places where the user experiences something confusing and has to wonder whether the system understands its own state.
The image routing fixes are especially important because they reinforce the main theme of the release. Explicit image model configuration now wins where it should. Native vision skips no longer wrongly erase downstream inspection opportunities. Codex image models get bounded app server image turns, and complex reference image edits are restored with guarded multi-part uploads.
Which tells you something about the team's priorities. They are not satisfied with, technically yes, image generation is supported. They are trying to make the route behave correctly under realistic conditions, which is what determines whether the feature becomes dependable.
There is also meaningful cleanup around stale or incomplete model catalogs. Missing OpenAI Codex /GPT 5.5 rows can be synthesized when Discovery omits them, and stale Codex rows are suppressed. Again, that is not glamorous, but catalog drift is exactly the kind of thing that produces maddening operator confusion. A model appears in one context, disappears in another, routes oddly, or carries stale metadata.
Then you get the security and trust boundary layer. Gateway config editing gets hardened. Webhook secret refresh behavior is tightened. Clear text rules around Android and pairing are addressed. Teams token validation improves. Plugin setup resolution is safer. Discord access enforcement is tightened. MCP bridge exposure is constrained more carefully. And there are fixes around metadata paths that could create prompt injection adjacent problems across chat transports.
That last part matters because the surface area of modern agent runtimes is huge. It is not just prompts and outputs. It is channels, metadata, webhooks, bridges, tool messages, auth state, and transport-specific formatting. The attack and failure surface expands with convenience. So a runtime that wants to be taken seriously has to keep doing the unglamorous work of closing weird edges.
Which is why the practical read on version 2026.4.23 is not simply more features. It is OpenClaw trying to make three surfaces more real at once: media generation, agent delegation, and operator trust.
Image work gets easier to route. Subagents get a better context control model. And a long list of correctness fixes tries to stop auth, transport, and metadata edges from turning into user-visible nonsense.
There is also a bigger product lesson hidden in that kind of fix list. Users rarely describe their satisfaction with a system in the language the changelog uses. They do not say, "This product improved multipart upload recovery and bounded app server image turns." They say, "This system feels smoother now." Or, "This system stopped doing that weird thing." Or, "I trust it enough to try the more ambitious workflow."
Which means quality improvements often arrive socially disguised. Internally, they are dozens of precise engineering corrections. Externally, they show up as competence. The operator hesitates less. The builder reaches for the tool more often. A teammate is willing to rely on it in front of other teammates. That is a huge threshold shift, and it is usually purchased with exactly this kind of invisible maintenance.
That is why the middle stage of a product's life is so demanding. The team has to keep expanding the surface area while simultaneously removing weirdness from the surface area already shipped. If you only add features, the product becomes wider and less trustworthy. If you only harden the old surface, the product becomes safer but stagnant. The releases that matter are the ones that do both.
And version 2026.4.23 does both in a fairly disciplined way. It opens new media paths, makes delegation more flexible, extends control over slow generation jobs, and spends a lot of attention budget on the messy work of keeping the runtime coherent across channels and auth states and provider quirks.
That is the kind of release that matters after the demo phase. Not because it looks gigantic in a headline, but because it makes the runtime more comfortable to actually live inside.
And from a builder perspective, that is the right lesson. The market is full of systems that can do impressive things once. The more defensible systems are the ones that can do useful things repeatedly without surprising their operators.
Which makes this release more important than a typical patch-level reading would suggest. It is not just refinement. It is the accumulation of refinements in exactly the places where trust is won or lost.
Now widen the frame. Google's planned investment of up to $40 billion in Anthropic is easy to read as a valuation headline. That is the loudest part, but it is probably the least useful part for builders.
The more interesting part is that the commitment is paired with more cloud compute, especially TPU access. That changes the meaning of the story. This is not just one giant technology company placing a financial bet on a frontier lab. It is a cloud and silicon provider deepening its importance to a lab that still matters at the model frontier.
Which means the relevant question is not, is Anthropic worth a huge number? The useful question is, what happens to frontier competition when access to custom compute becomes one of the main bottlenecks?
We are already watching the answer emerge. Model quality, rate limits, rollout speed, availability, and pricing are all increasingly downstream of infrastructure. The old fantasy was that model labs competed mainly on algorithms and data. In reality, they are competing on algorithms, data, and who can secure enough compute to keep the system running at the pace the market expects.
And that is why this Google story matters. Google is not just another investor with a checkbook. It is a company that can be a competitor in models, a vendor of cloud infrastructure, a supplier of custom silicon, a distribution layer, and a strategic investor at the same time. That is not a clean market structure. It is a deeply entangled one.
For Anthropic, the immediate benefits are clear. More money means more room to scale products and hiring. More compute means more room to train, serve, and iterate without infrastructure bottlenecks defining the narrative. But for Google, the upside is not merely ownership exposure. It is centrality. Every dollar and every TPU hour that pulls Anthropic deeper into Google Cloud increases Google's importance to the frontier ecosystem.
That is a major shift in how to think about power in this market. The cloud provider is no longer just a landlord. It can also be a strategic dependency with product ambitions of its own. The silicon vendor is not just supplying hardware. It is helping determine who can stay competitive at the frontier and at what cost.
And for builders, the main lesson is not to over-romanticize the independence of model vendors. A company can look independent at the application layer while becoming increasingly dependent on whichever infrastructure partner gives it the capacity to keep scaling.
Reliability is part of this too. When people complain about model limits or spotty availability, they often talk as if those are purely product decisions. Sometimes they are. But often they are infrastructure decisions disguised as product experience. If demand outpaces available serving capacity, the user feels that as limits, latency, or delayed rollouts.
And that helps explain why these giant funding and compute stories now matter so directly to downstream builders. If a lab secures a better compute relationship, it may be able to offer higher limits, faster launches, lower latency, or broader enterprise availability. If it fails to secure that relationship, the quality of the model might remain strong while the day-to-day product experience starts to sag under load.
Which also means the cloud relationship can shape strategic behavior. A lab under infrastructure pressure may prioritize certain customer tiers, bundle products differently, delay launches in some regions, or narrow access to expensive capabilities. From the outside, those moves can look mysterious or political. From the inside, they may be extremely practical reactions to compute economics.
So this story reinforces a broader pattern. The frontier model race is increasingly a compute control race. Not just who can design the best model, but who can keep the best model supplied, served, and distributed at scale.
That has strategic implications beyond Anthropic and Google. It suggests that every serious lab will need some version of the same answer. Either build your own infrastructure leverage, partner deeply with someone who has it, or accept that your product roadmap is constrained by whichever provider you depend on.
And once you see the market that way, the Google and Anthropic story becomes less of a celebrity investment round and more of a structural signpost. Frontier labs are not just software companies anymore. They are compute organizations attached to model research organizations attached to cloud relationships.
Which is why builders should care. Even if you are not training giant models yourself, the products you depend on are shaped by these upstream infrastructure relationships. Cost, latency, availability, and release tempo are all downstream of them.
This is what makes the story useful. It explains why the market keeps feeling more vertically integrated even while people keep pretending the layers are separate. DeepSeek's new V4 preview matters for a very different reason. Not because every benchmark claim should be accepted immediately, but because the announcement keeps the open-weight side of the market firmly inside the cost conversation.
The company is talking about a 1 million token context window, very large mixture of experts' designs, and pricing that undercuts frontier closed model options. Even if the final real-world picture ends up more modest than the announcement suggests, the strategic signal is already clear. Open-weight and open-adjacent systems are still compressing price and making premium model vendors justify their margin.
That matters because the practical adoption question is rarely who has the absolute smartest model in the universe. The practical question is what capability you get at a price that feels sane for the workload. Once a model is good enough on long context text, code, and retrieval-heavy tasks, cost starts to matter a lot.
Especially for routing decisions. If a huge context window and lower cost make it viable to run broader classes of analysis or lower stakes reasoning on a cheaper model family, then premium closed models become something you reserve for the turns that truly need them. The open-weight side does not have to dominate everything to change the economics. It just has to be good enough often enough.
This is why price pressure is strategically powerful. It changes architecture choices. A team that once routed every serious request to the most expensive premium model may start splitting the workload. High-stakes reasoning stays premium. Batch analysis, broad retrieval, exploratory summarization, or long code-based scanning move to something cheaper.
And that gives operators leverage. Once you have credible alternatives, even imperfect ones, you stop relating to the premium vendors as if their current price is the natural price of intelligence. It becomes one option in a routing strategy rather than the unquestioned default.
The 1 million token context claim is especially interesting in this light. Long context does not automatically equal strong reasoning, but it changes what workloads feel plausible. Large code repositories, long legal or financial documents, big research bundles, sprawling issue histories, and chunk-heavy retrieval flows all become easier to justify if the cost floor is low enough.
There is also a market psychology effect. Every time an open or open-adjacent model family closes the gap even partially, the premium players lose some narrative safety. They can still win on multimodal breadth, better safety systems, enterprise guarantees, and often absolute quality. But they have to explain why those differences merit the price they charge.
And that explanation gets harder when the cheaper side keeps moving. DeepSeek does not need to become the universal best model to matter. It just needs to make the premium side more nervous about complacency.
Which is why this is worth paying attention to even in preview form. The market lesson is immediate even if the benchmarks evolve. The open weight side of the ecosystem is still exerting downward pressure on price and upward pressure on expectations.
Builders should treat that as good news and strategic warning at the same time. Good news, because it expands the set of economically viable workloads. Warning, because it means your architecture should probably assume a more competitive, more fluid routing environment rather than permanent dependence on one expensive premium path.
And that connects back to the OpenClaw release in an interesting way. Multi-provider systems become more valuable when the market underneath them is moving on both capability and cost. Better routing surfaces matter more when the spread between premium and cheaper options is actively shifting.
Exactly. The faster the model market moves, the more valuable orchestration becomes.
The last story today is Vercel's updated breach disclosure, and it is the operator warning that deserves to stick in your head.
The new detail is that Vercel says some customer accounts showed evidence of compromise that predates the breach window it originally disclosed, and that more customer accounts tied to the April incident have been identified as well. That matters because it changes the mental model of the event.
Right. The first version of a security story is often temptingly neat. One employee device. One bad download. One initial foothold. One breach window. One contained blast radius. But attackers do not organize themselves around the neatness of the incident report.
What this update suggests is a messier and more realistic picture. Once attackers get access to developer machines, tokens, environment variables, or related account secrets, they do not need a story that looks elegant. They just need an opening that keeps paying out. From there, internal systems, platform APIs, customer-linked infrastructure, and deployment secrets can all enter the blast radius.
And Vercel occupies a particularly sensitive part of the stack. A developer platform is not just another software vendor. It often sits close to production deployments, account integrations, environment configuration, project metadata, and privileged operational controls. A compromise there can spill outward quickly.
Which is why the main lesson is not only about Vercel. It is about hosted developer platforms in general. Modern software operations concentrate huge amounts of power around developer credentials and automation secrets. If attackers get those, they do not need to own every downstream system directly. They can often pivot through the platform that already connects to them.
The update is also a reminder about disclosure psychology. When a company first reports an incident, the first report is usually a beginning, not an ending. Early disclosures reflect what is known at that moment. As investigators widen the search, the story often becomes older, broader, or stranger than the first version suggested.
Which means operators should resist the comforting instinct to treat a narrow first disclosure as final scope. If the first disclosure sounds tightly bounded, that may simply mean the investigation is still early.
The infostealer angle is especially worth emphasizing. People still sometimes talk about infostealers as if they are a consumer malware nuisance rather than a core infrastructure risk. But in a world where developer machines hold tokens, browser sessions, cloud access, deployment credentials, and environment secrets, infostealers are direct platform compromise tools.
Exactly. They are not side-channel annoyances. They are one of the fastest ways to move from one person's machine into organizational power. And once a developer platform is involved, the compromise can affect far more than the initial endpoint.
There is another uncomfortable implication here too. The more companies centralize deployment, secrets, observability, previews, and integrations into a single platform, the more efficient that platform becomes for users and the more attractive it becomes for attackers. Convenience and concentration often grow together.
And that creates a real governance challenge for engineering leaders. The same simplification that makes a team fast can quietly make the blast radius enormous. One platform login can unlock previews, production deploys, build history, environment configuration, and third-party integrations. That is wonderful on a normal Tuesday and terrifying on the Tuesday when someone steals a session token.
Which is why platform hardening cannot be reduced to password hygiene alone. It is about shortening secret lifetimes, reducing default privilege, watching for anomalous agent or automation behavior, limiting how much any single credential can reach, and rehearsing the assumption that an endpoint can become hostile even if the employee is acting in good faith.
That is why platform security incidents matter beyond the vendor involved. They are stress tests for an entire architectural style. They show what happens when a lot of operational power sits behind a few identities and a few integration surfaces.
So the practical takeaway is simple. If you run modern hosted developer tooling, treat credential theft and endpoint compromise as first-order risks. Rotate secrets. Reduce token sprawl. Segment access where possible. And remember that the first public shape of an incident is often the most flattering shape, not the final one.
This is the ugly operator lesson of the week. The real incident is often bigger than the first story.
So that is the map for today. OpenClaw version 2026.4.23 earned the front because it pushes image generation, Subagent context control, timeout handling, and a long list of operator correctness details in a direction that will actually be felt in production.
Google's Anthropic commitment showed that frontier competition is increasingly a compute and cloud control contest, not just a model quality contest.
DeepSeek kept pressure on the pricing story by reminding everyone that the open-weight side of the market is still compressing costs and expanding what economical routing can look like.
And Vercel reminded everyone that platform security incidents are usually messier, broader, and more operationally revealing than their first disclosure suggests.
If there is one through line here, it is that dependable systems win. Not just systems that can do impressive things, but systems that can be routed, trusted, governed, and recovered when the real world gets involved.
Thanks for listening to OpenClaw Daily. Find more at tobyonfitnesstech.com.
We'll be back soon.
I'm Nova.
And I'm Alloy.